Hey everyone, my name is Michael, and today I want to have a look at how we can build in aggregations into our connection types. With our Chocolate 15.1, we introduced a new connections API, and I'm going to have a look at how we can customize it. Before we get started, if you want to have the source code of this episode or any other episode, head over to tv.chillicream.com. If you like our content, please hit the like and subscribe button below the video. And with that, let's dive in. So this is my typical demo project built around the Microsoft eShop. And specifically, we are focusing in here on the catalog API. So what we want to do is integrate some aggregates on top of our connections that we have. So what is a connection? Let's quickly have a look. I'm running this. Then we head over to Nitro, create a new tab. And if we go into our schema here, let me go into the column view. I go here into the query type, and then you can see we have here brands, for instance. And brands has a connection. This connection is our paging type in GraphQL. It's standardized, it follows the relay specification, and it's best practice for GraphQL. It's called connection because it's meant to connect two nodes in our graph, into our mental graph, which represents our business model. So on top of this is where you should put your aggregations or metadata around the nodes that this connects to. In our concrete case, what we want to have is actually when we go here to brand, you can see that we have here products. This is our products connection at the moment. And on top of that, we want to have aggregates. Aggregates by product category. So we want to see per brand aggregates around the product category like average price or max price or the lowest price that you get for a product in a category. So this is pretty simple, and I already built some logic into our business layer. So if I go here to the services and to the product type service, you can see down here we have get aggregates. And I can get here the aggregates by brand ID. And it will generate, as I said, a couple of aggregates like average price, max price, min price, or how much products I have in a product category. But how can we bring this into our connection? This was quite tedious in the past with Hot Chocolate, but it's now super simple with our new connection API. And I'm already using this new connection API here in my brand type. So I'm going here to the brand node, and then you can see that this get products uses the page connection here. So how do we get some aggregates onto our page connection? It's actually very simple now. We simply inherit from page connection. So I'm going to introduce here a brand products connection. So why this name? Because this is now a unique connection. And I don't want to collide with other connections around products. So we call that brand because it's from brand to products, the connection. And then we simply inherit here from the page connection, pass in product. And then you can see it wants me to implement here a constructor. I'm going to do that. And I'm using a primary constructor here simply. And then I get here the page. That is actually what we already have here. This is a page of products, and this is a green donut page. So this is a way how we do paging in our business layer. And we also have here a max relative cursor count, and that's set to 5 by default by the base type. We keep that. I have a video on relative cursors. You can check that out. But in this episode, we ignore them. So I'm just passing them through. So now to get the aggregates in here, I simply introduce a resolver here, and my aggregates are a read-only list, and it's a read-only list of product type aggregate. Pass that in here, then we say get aggregates async. We need the product type service, and this is a standard resolver, so you can inject it like in any other resolver in Hot Chocolate. So we do that here, then we also want the cancellation token, and then we are good to go. So we need one more thing here. So when we call the product type service to get the aggregates, you can see that we need here a brand ID. So we simply pass it along and then pass this into here. So one thing, because we have this list here, let's quickly write this operation. So what we want to be able to is explore here the brands. Let's take the first two. Then from the brands, go to products, and then want here, let me also get the first two, and then here want to have the items if we want to have this list, but we also want to simply go to the aggregates here. So we don't have this field yet, but we want to have the aggregates and get a high level overview of what the most expensive product is per category points. So this executes, but because we are working here with nested pagination, we really need a data loader. And I already implemented the aggregates here. These are my aggregates in a data loader. So you need to make sure that you do that in a data loader. Otherwise, you will have an explosion of cost with lots of queries being executed. So I'm back here. I implemented that. This service will, as I said, use here the data loader and then batch all these aggregates together. So with this in place, we simply take this new class and we use it now here as a return type. It's basically as before, just that we pass along the brand ID here, and then we are actually done. So I can just run that. We go over to Nitro, refresh the schema quickly. Then we have these aggregates here, and we, for instance, get for the category the max price. So what's the most expensive product price that we have per category? And you can see now in this category, which is, I think, air strider. Okay, this air strider. And in the category cycling products, the most expensive product is 129. We could also look for the cheapest product now, which is $54, right? So you can see that now per category. So this is awesome. And if we look at the SQL here, you can see here the aggregates, then here the paginated results, and here the initial root query. So we have 3 SQL queries here, which is super optimized with data loaders.
If you're building with GraphQL, you need the right support to stay ahead. The Chili Cream support plans give you direct access to our experts, priority bug fixes, and even a say in our roadmap, so you can shape the future of the tool you are relying on. Check out the options to find the right fit for your team. And with that, let's go back to the problem at hand.
What happens actually when I don't want to have the products? Well, let's have a look. Maybe I just want to drop these and then execute, then have a look at the SQL. And you can see here are my aggregates. Then we are still doing the pagination. And this is really clear if we look at the resolver here, because we always execute here the business layer to get the product page in any case. And then if the aggregates are selected, we also run the aggregates. If we don't select the aggregates, we wouldn't run the aggregates, but we still would run the paging data request, right? So how can we optimize that? And with Hot Chocolate 15.1, we also introduced something called connection flags. Before I show you them, let me show you one other thing. So each of these connections that we have here are now translated by our source generator in real C# code. So I can go here, look for the brand's product connection. This is this guy here. This is the product connection type. So what we do is actually create a full fluent type that is representing the class that we wrote there, where you can see here's the aggregates resolver. And if I go down here, you can also see the implementation of the actual resolver code. So this is now very transparent what is happening underneath when I do this. And I could also look here at the brand node. This is the type where we have the products field on, and there I can go to the resolvers in here. By the way, this is also just the Fluent API up here, get products, and then down here you have the compiled resolvers, and you can really see what is happening in here. In our case, we are going to inspect here actually the paging options. Then we are getting something which is called the connection flags, which tell us what kind of data we need for this resolver. And I can use these connection flags, as I said, to optimize what is happening here. So we can simply say, actually, give me these connection flags. And then if I'm not fetching any paging related stuff, so if connection flags is none, then we not need to execute actually here to fetch this products page. We simply return an empty page because the user didn't request that data, so we don't need to produce it. And then we can just say, in the other case, if there's anything paging related being fetched, then we're gonna execute this method. Okay, with this little change, we're gonna rerun it. So if I just want my aggregates, and run that here, go to look at the SQL, you can see we fetch the brands and we fetch the aggregates. We're not fetching the page. If I now also go for the page and fetch the products here, run that, then we get the aggregates and we get the page and also batched. If I don't want the aggregates and just want the page, I don't pay for the aggregates. I just get here the paginated data and the brands. If I, for instance, also want the count, then I get the count here. And in this case, you can see I'm fetching here the page, but I'm also batch fetching the count. This call is split transparently. To inline the count here would be too complex. So in this case, where we have batching involved, we will split this and have two cores running in parallel to fetch these two things. And this is totally transparent for you. It's just handled by the Green Donut Data API that we are using in the backend here. If I go here to the products by brand, you can see that we are using here data loader to get products by brand. If I look at the data loader, you can see that we are doing here a 2-batch page async. And this handles actually these kinds of things. What we do in the resolver compiler is to use the connection flags internally to construct here the paging arguments and tell the paging arguments that we don't need a total count or that we need a total count. Awesome. With this, we're actually done. You can see how easy it is to extend this thing and how transparent it is to reason about what is happening, what Hot Chocolate is doing underneath. You can simply look at the code. And we also re-engineered here the way that we produce here source-generated code. You have nice files for each file that we produce. We have here a generated output. So it's easy to reason about what's happening here. For instance, you have brand, connection type. You also have the edges. So if you want to put something on the edges, it's the same procedure, right? I could go here to the brands connection and in this case say I actually want to have my own edge type, and then you could produce it and use not page connection but the connection base, which also allows you to change the edge type, and then the compiler would pick that up and produce you the source code for it. So sound out in the comments, how do you like this new way to extend the metadata on the connections, on the edges? And are you already using the new connections? I already had an episode on them. So do you had time to try them out? Did you do so far? With this, we are at the end. I'm going to see you next time.